Hi, welcome to the tutorial on feature preprocessing. By the end of this tutorial, you will be able to describe feature preprocessing. There are various methods to perform feature processing. In this tutorial, we will look at the most widely used method, that is feature transformation. Now, as the name suggests, it is a method to transform the features using mathematical operations. For example, look at the plot showing relationship between target and a feature. This shows that the relationship is non-linear. And we know that for some models like linear regression, it is necessary to have a linear relationship between the dependent and the independent variables. So in this case, we should transform the input variable in a way so that the relationship between the target variable and the feature is linear. So this method is model specific. Let's look at another case where feature transformation will help us model better. For instance, the plot shown on the screen represents a right-skewed or positively skewed distribution. This may be due to the presence of some outliers in the data. Now, we know that in linear regression, having normal distribution is preferred over skewed distribution, as it is easier to model the relationships. Also, some modeling techniques perform well when we have a normal distribution of variables. So, whenever we have a skewed distribution, we can use transformations which reduce skewness. Please note that when we say data is right skewed, we mean that the peak or the hump is on the left, and when we say that the data is left skewed, the peak or the hump is on the right. Note that for right skewed or positively skewed distribution, we take square or cube root or logarithm of variable, and you can say that the nth root as well. And for the left skewed or negatively skewed, we take square, cube or exponential of variables. This is called feature transformation. Let's try to do this in Python. Take a special note that we are using raw housing prices.csv here. You might ask, why this data? We are using this data because this data was saved right after treating the missing values and outliers in both target and the independent variables. Also, we have not yet performed any kind of transformation with the independent variables in this dataset. Therefore, we have an opportunity to start with a clean slate and to demonstrate feature engineering. We will begin with the variable flat area, as we know that the best and easiest way to check the distribution of any variable is to plot the histogram. So let's do that. We can clearly see in this plot that distribution of flat area is right skewed in nature. Flat area being the right skewed distribution would be perfect to demonstrate the process of feature transformation. For this, we define a simple function called log transform. This function takes some sample data as parameter and returns the log of it. Now we use this function on the column using the pandas.map function. This converts the elements of the flat area to their logarithm values. We are storing the new column in new column transformed flat area. Now obviously the next step would be to visualize the new column. This is what we wanted. The feature transformed area now looks very much like a normal curve. We would strongly suggest you to revisit the regression implementation and transform the skewness of some of the continuous features using the log transformation and draw out the results. You will be surprised that the R-square will increase further than what we have obtained. There are also other types of feature transformations which we have seen during the data exploration phase of the target and the independent variable. We will cover the ones we have already seen before briefly in the next video. See you there.